So, like many in the tech community, I want to know how could I get into Google. So, luckily, Google has posted on their careers student section. This guide provides an introduction to students as to what Google is looking for and what the relevant skills you should learn while you're seeking an internship at Google. So this guide is good for both those who are currently studying computer science and those who are graduating, and it's just a brief overview on each of the topics, and they provide resources to get you started to be best prepared for a Google internship. So what is this guide used for? Basically, it's just to keep you on track, and so you know what is worth looking into and what Google thinks are the most important things they should check out. So it just gives you a cursory overview of all of the subjects that Google thinks would be good background experience for an incoming intern to have. So this isn't meant to be your entire course of study. This is just meant to give you a brief insight in each one, and you can specialize into one that you're more interested in as you get a taste of all of them. So the online resources they provided, just to reiterate, are not to replace your educational experience, but rather to supplement it and to help you further grow beyond what is offered in the classroom. So this is gathered from the students they've worked with and other candidates in the field. And this is supposedly a work in progress and a living document that I'll be constantly updating. I've been checking in this for a couple of months, and there hasn't been any changes or updates. However, they may be making updates with each new internship class because I have not been checking in for over a year. So they may do these checkups for each internship class that comes in, and there just hasn't been a new internship class since I've been looking at it. So they say that you don't need to go through them in order, and they can go through in any order. At least the first handful of them, I think, are good to go into order if you don't have already have an in-depth computer programming experience. If you do already have experience, let's say you're a junior in your program, then maybe you can skip around a little bit. But overall, this is a very good structure to follow. Not everything is exactly like sequential in how you should learn it. But the first couple I think are crucial that you do in order. So the first one's an introductory computer science course. This is just a Udacity course. It teaches you the basics of Python programming and the very basics. So if you already know how to create a function or use recursion properly, and you've already worked on like a final project for a course or something using a programming language, you're probably at about this level. And you could continue or you could skip over it. If you're new to programming, or let's say you've only done like a single programming course, this might be a good one to look into, and it's also an introduction to Python if you haven't worked with Python yet. Then after that, that's mainly function level abstraction programming. So the way you're programming is you're creating procedures and you're following through in order, and you could have some function calls. And now after that, they want you to focus on an object-oriented programming language. So many languages that you may have used, Java, C++, C#, Python, these all have object-oriented components to them. Not all of them require for you to use the object-oriented parts, but like something like Java, if you've programmed in Java, you may have unknowingly already done object-oriented programming. So object-oriented programming is just another layer of abstraction, while in the introductory course, you would have done functional abstraction. In object-oriented programming, you're doing object abstraction. So you're not only are you having functions that you're creating, but you're now also creating objects which have their own variables or states, attributes, maybe other words you've heard for them, and they have methods, which are just functions associated with an object. So they provide two different sorts of resources for beginning programmers, which is sort of an introduction into object-oriented programming, and then they give you for more experienced programmers, because you can definitely go in more in depth, and they teach you how to craft quality code and basic data structures in an object-oriented language. Then the next thing that they write is learn other programming languages. So why learn other programming languages? Most programming languages are versatile, and you can kind of, from any programming language, you can make most other programs. However, there's definitely better tools for there's definitely better tools for creating different parts of a programming there are definitely better tools for creating different projects. So, for example, if you're trying to create something that's on the web, HTML and CSS, JavaScript, that's the way to go. That's probably the easiest way to go. And if you're working on the server side, you could add in PHP, Python, Elixir, something like that on the back end. However, let's say you're working on a list processing, then something like Lisp would be a much better tool to use. With the functional programming of that, it's horizontal. It's horizontally scalable, and it just makes everything. It can run it can run a lot of things much quicker. Or like for Elixir for the backend, if you're running on AWS, you can leverage the horizontal scaling. So they give you Codecademy as a resource. There's lots of good online resources on YouTube too. There's this specifically Derek Bana's. If you already know how to program and you just want to see how to begin in another language, he does really good one-shot videos of he just goes over the very basics of the entirety of a programming language, and those are really good videos. I find for myself those are very good. Just do along with him, and you just see. Okay, you get the basics and you just start picking up on that programming language fairly quickly. You're not going to master it from the one course. You're not going to have learned it from the one thing, but it's a good get your feet wet, touch on all the basics, and then go back over what you actually need to use. So learning more programming languages is like adding more tools to your tool belt. So while it's not really necessary in a sense, building everything with a hammer is not a good idea. The next step that they give you is to learn how to test your code. So testing your code, which would include how to catch bugs, creating tests, and breaking your software. I believe, but don't quote me on this, that Google is a test-driven development workplace, which means that they follow what I dub the red-green refactor policy, which is first you create tests that'll fail. That's the red light. So it's important to make sure that your tests fail at first, because you don't want to create a placebo test that make it appear like, oh, once this is working, then everything's good, and then it's immediately green light, everything's good, and you're like, wait, I haven't even programmed anything yet. So you have to make sure that first your test fails, and that it tests what you're looking to test. Then green. So for red-green refactor, the next step would be green, and that's getting your code to pass. Brute force, just however you can just make sure that it works. So now it's doing what it needs to do. The final step is refactor. So now that you have functioning code, you go back and you clean it up. You take into account time and space complexity, depending on whatever your constraints are. You try to optimize the code. You want to make sure your variables have good names, your functions have good names, so it's easily identifiable and easily readable. You want to add in some documentation so people other than yourself can look at your code and understand what's happening. And they provide 2 Udacity courses for that. The next one is logical reasoning and knowledge of discrete mathematics. So discrete math could include stuff like graph theory or Boolean algebra. So in geometry class, if you ever did like if P then Q or like modus tollens, if any of that seems to ring a bell, any of that like proof making, that all falls under part of discrete math. Discrete math also covers some basic number theory, and they provide some resources there. There's also a couple of good books that I've come across, and I can link those below, that are really helpful for learning discrete mathematics. And discrete mathematics, of course, is a very important branch of math to know for programming, because while it's not super, number heavy in a way, it requires a lot of logical thinking, and that's what you'll need to be a successful programmer. Next up that they give is develop a strong understanding of algorithms and data structures. So data structures and algorithms is pretty much your bread and butter. So if you don't know this, you probably won't get the internship. This is most likely what you'll be tested on during your interview, and a lot of the coding problems you'll be assigned will probably be surrounding algorithms and data structures. Not necessarily every question, but it's your bread and butter. And if you don't know these, you're kind of lacking that. You're kind of lacking the skill set required to be a software engineer. So you're going to learn basic data structures, algorithms. You're going to learn how to do big O notation, how to understand time and space complexity, asymptotic. I lost the word. But yeah, so this is your bread and butter course, and you're gonna have to need to know basic data structures and algorithms. In addition to the resources they provide, specific for programming interviews, I would recommend 2 books: Programming Interview Exposed, and the number 1 book for programming interviews, Cracking the Coding Interview. If you've already started cracking the coding interview, no need to go into Programming Interview Exposed, but Programming Interview Exposed is a good overview before going as super far in depth as cracking the coding interview goes, because cracking the coding interview is a lot of examples and a lot of practice code, and Programming Interview Exposed is a lot more overview of each of the subjects. So if you don't have a ton of experience with it before, I'd recommend doing Programming Interview Exposed first, and then cracking the coding interview. And of course, I can leave links for those in the description. Next, they want you to develop strong knowledge of operating systems. This is the area where I haven't actually gone through their YouTube course. I've done one at my university. I'm not sure how closely they are linked. I've only gone through, I think, 3 lectures in their course in the UC Berkeley YouTube series. But operating systems are important to know so you can optimize your code. You understand how your code is working, how it switches between processing, and how to properly design your code to pipeline so that when you're doing concurrency, that the operating system knows how to, or that your code is easy for the operating system to read and to properly do process scheduling on. And I'm sure that they go through a lot more in depth in the UC Berkeley course than just the topics that I just briefly touched on. So then the next one that they go into is learning artificial intelligence or machine learning. And this is actually where I have a really strong interest. I've started looking into machine learning and AI, and I've taken actually took a Coursera course that was from Columbia, which isn't on there, which I would really recommend. Is through edX. And I believe that that's really good just for getting a very, very basics. The first week is just cursory overview. You could ignore the first week of the Columbia one and then continue on. The rest is actually really good. So you want to learn AI and machine learning. They give you some really good resources from Udacity and from Stanford, which Stanford, I haven't looked at other resources. If their machine learning course is the one that I'm thinking of from Andrew Ng, it's really good, and that's the one that you should be looking at. I'm not sure if it's that one, but he's one of the leading people in the machine learning field, and he's an awesome person to learn from. The next topic is Android development, which is they provide you Google developer training for Android, just in the title, and just also web development. They have Google developer training for web, and for the other developer skills, they provide you with the Google developer training site. Custom from Google. I think this is probably a good source to learn to know what Google wants for their interns. So Android development, I'm going to guess that those courses are mainly in Java, but Google is starting to go over to Kotlin, which is now becoming a first-class programming language native to Android. And that'll be really good because Kotlin just provides a lot of things where Java's clunky. Kotlin just makes things a bit cleaner, a bit nicer. I've just begun learning Kotlin myself, so I'm no expert in it. And I'm sure that there are things that'll be pain points in it too. But so far, my experience with it has been very nice. Then learning web development. HTML, CSS, JavaScript, and probably Bootstrap, and just teaching you how to make responsive web pages, and I would guess different web kits, but I'm not sure exactly what's covered in their course. I haven't gone through their course. I've done the course at my university, and I've done my own work in web development. And then other developer skills. I'm not exactly sure what other developer skills would entail, but you can follow through on the link and see exactly what they cover. I know some of them are the web development and the Android tracks, but I'm sure that there are other tracks as well. The next topic that they have is cryptography. So they have 2 courses, one from Stanford and through Coursera, and one from Udacity. So then I believe that's just about the end of their coding. What you need to learn programming wise, and then it goes into a lot more projects and practice sort of area. So working on projects outside the classroom. So they give you a couple of examples of different project directories and archives from Google Summer of Code, and a couple of capstone projects that they've shown. So if you work on any capstone projects, any big courses that you have that have projects, Going to hackathons is really good for this also, or that pops up later on. But going to hackathons is really awesome for this, because you can develop a project in a weekend, and you have something to show, a tangible thing afterwards. So you go with a group, you work on a project, and you have something to show. You can continue working on it, clean it up, make it nicer afterwards. You could potentially win prizes and stuff. Like I won a 1 terabyte hard drive down in Hackathon, DC. So I would rate that a really good experience. So then you can work on a small piece of a large system and read and understand existing code, track down documentation, and debug. So the resources they give are GitHub and Kiln. There's also a couple of other places. I guess they're more workflow. If you're working with a group of people that you can use Cloud9 or you can use Bitbucket. And but GitHub and Kiln are really good for finding other people's open source things and helping contribute to that. They want to know that you can work as part of a large code system because Google itself is a large code system. You have to be able to track down documentation yourself, debug, read and understand the code that's already there that you didn't write. So you have to learn how to understand other people's code, which is a different skill from being able to program yourself. Work on projects with other programmers. As I said, hackathons are great for this. Group projects, just working on passion projects on the side, and working with open source as they have above. You could also work on pair programming and code reviews working alongside with other people. So then for the next area, practice your algorithm knowledge and coding skills. ACM ICPC, I'm part of a programming team at my university, and that's been really good. They have code jams. Also, you could some other good sites are Top Coder, HackerRank, and OpenCaddis, or I think it just goes under Caddis now. And those are great sites to practice your algorithm skills and give you examples that are very similar to ACM ICPC. Especially Caddis is really, really close to ICPC. But I personally like HackerRank just because they have a lot of examples and they have cracking the coding interview, more interview-esque questions, while Caddis has like programming competition questions, which are, I would say, a little bit of they're a bit of a different genre, but bit of a more difficult caliber than they would give you on an interview. And so the kinds of questions they ask might be a bit different in the programming competition, but it's definitely good practice either way. The next thing is becoming a teacher's assistant. At my university, I'm a teaching assistant. I've taught Programming 1, Introduction to Computer Science, and Data Structures and Algorithms. I'll be the TA for this upcoming semester. Also, let's say you don't have the ability to TA directly under a teacher at your school, or let's say you're graduating. Teaching online or perhaps being a mentor for someone else is really important. So I think that there are three important people in everyone's lives that you should have at any point for your programming career, and which is your mentor, someone who knows more than you, someone you can learn from, someone that you can go to when you have problems or questions. This person is really important because it helps you grow and learn more in areas where you might get stuck. And you want it to be someone who's proficient in a field that you want to get into. Then the next one is your peer, which is someone that's at your level, someone you can work alongside, work on projects with, and you can also use for accountability. And then you want a mentee or like a student of your own, an apprentice of sorts that you can teach, because when you teach, it helps solidify the subject matter into your own head, and it helps enhance your own knowledge when you have to explain it and come up with analogies to help others explain it. And I found that being a TA has been a great help for just becoming a better programmer. And finally, gain internship experience in software engineering. Now, you might be listening to this because you want an internship at Google. It's hard to get an internship at Google if you don't already have internship experience. So this summer, I'm interning at Financial and Health Services. I'm not sure if I can disclose the name because I'm under NDA, but if I can, I will disclose it in a future video. But they provide software solutions for health and financial professionals. It's a international company, a pretty big company, but not necessarily one that you'd recognize the name. But yeah, so this is the basic list that Google provides, saying if you hit all these points, then you then hitting all these points puts you in a good position to be able to be a Google intern. It does not guarantee you a position, but going through all these things will. I'm considering doing a challenge in which I go through each of the things and I try to consolidate and condense and post all these on my channel. So please let me know if this is something you're interested in. Please like, comment, subscribe, and have an awesome day. And don't forget to be awesome.